All right, we're reviewing these three lessons, 7, 1, 2, and 3. 7, 1, and 2 were, 7, 1 was adding and subtracting polynomials. 7, 2 was multiply and divide. And 7, 3 was like special multiplying. And so if you're like, what the heck is that? Don't worry, we'll get there. So first, find the sum or difference. Write your answers in standard form, which means highest degree to lowest degree. Well, looking at all of these, let's see. All of them appear to be in standard form now, which means that we will not have to do any rearranging once we're done, because if you start in standard form, it's pretty easy to end in standard form. So for number 1, 2, 3, 4, 5, and 6, that is the add and subtraction, right? So basically all we're going to do is go, hey, look, here's negative 4x. We're going to be adding 6x, so that's 2x. Here's 9. We're going to be adding negative 14. That's negative 5. And it's in standard form, and we're done. Now, if you want to rearrange this, be my guest. But I think most of you are pretty capable of doing what I just did. Number 2, t squared plus, oh wait, I was wrong. This one's not in standard form. So, okay, no big deal. T squared plus 2t squared, that's 3t squared. So here's what I'm going to do. I'm done with that one, done with that one. So let's do 3t cubed plus negative 2t cubed. That's positive 1t cubed. And since this term is positive, we're just going to go ahead and write plus, right? We're done with him. We're done with him. Negative 3. Oh, look. He doesn't have a like term either, so we're just going to slap him on the end. He doesn't have a like term, but it is positive, so plus 17. Now we're done. Are there any others like that? Yeah, this one. Anyway, this one's kind of funky. It's 3a squared minus 4a squared. So that's just 3 minus 4. That's negative a squared. Okay, and then plus 1. Well, here, inside of these parentheses, we can go ahead and simplify this. Positive 1 minus 9 is negative 8. And then negative 8 minus 8, that's negative 16. And then now we just do this last one. It's minus negative 3, that's plus 3a. We're done with that one. Negative 5h minus 7h, that's negative 12h. Negative 2 minus 6 is negative 8. Number 5. All right, so this one has the check mark because it is not in standard form like I thought it was. But that's no big deal. As we kind of saw already, we can really just kind of go through and pick out, okay, what's the biggest degree term? There and there. So 6 minus 5 is 1. K squared minus negative 3, well, that would be a positive then, so this is plus 4k squared. Let's see, he doesn't have any friends, but remember he is negative, so negative 7k. And last is just negative 4, and we're done. Number 6, dang, another one that's not technically in standard form. 8h squared plus negative 12h squared. Well, that's negative 4h squared. Negative 7h plus 9h. That's 2h. And plus 4. So that was 7-1. Okay, so all of this, 7-1. All of this, 7-2. Now, 7-2 was, like I said, multiplying and dividing. Notice these are all multiplying. And we talked about 4 different ways of doing this. I think the first method that we actually did was the box method. And if you're like, what is the box method? Well, here, I will do number 7 as the box. So here's the box, x minus 2. X minus 1. And here's the box that would contain that. And the idea is that now it is x times x is x squared. X times negative 2 is negative 2x. Let's see, let's go back to yellow. Negative 1 and x is negative x. And negative 1 and negative 2 is positive 2. And now you just combine all of those terms. X squared, we're done with that. Minus 3x, we're done with that and that. Plus 2, we're done with that. So that was the box method. If you like it, great. If you don't like it, don't use it. So there was the box method, and then 2, I can't remember what's the next one was after that, FOIL, which stands for first, outer, inner, last. Now, I put the asterisk next to FOIL because it is both the one I love and hate. I love it because it's technically what I use. Technically, I hate it in that it only works for 7, 8, 9, and 10, and 11, sorry. And 14. Technically, it's not going to work for 12 and 13 because of the strict, like, hey, you're following very specific steps, so let me show you what those specific steps are. So to do here, let's zoom out so it's on the screen. First, we'll do first in purple. These two terms are the first two terms in their respective parentheses, right? So 3n times n, that's 3n squared. The outer terms, whoa, that's on the outside, that's on the outside, that's plus 3n. The inner two terms, these two are the inner two terms, that's minus 4n. And the last terms, well, these are the last two that have not been multiplied. And now you add it all up and you get 3n squared minus n minus 4. Okay. So I said that I love it and hate that because here's what I would rather do. I just use the distributive property, which is going to look exactly like that. Okay. And if you're like, I don't remember him doing that. Well, here, I'm about to do it right now. So, in fact, here, I'm going to erase up here so that I can have proper arches. Okay. So what I mean by that is I just look at this as I'm like, hey, this guy has two terms. And this guy has two terms. I just need to make sure that every term gets multiplied by every term. So I just start with h. That's the first term in this parentheses. So h times h, it's h squared. H times 4, that's 4h. Now I'm done with that term. So move on to negative 2 times h, negative 2h, and negative 2 times 4, that's negative 8. Now compare back and forth. Remember how I said this is FOIL? I mean, doesn't it look like I've done the exact same things? Because, in fact, I have, right? Okay, well, like I said, I don't like FOIL because it doesn't work for 13 or 12. And if you're, like, wondering why, because how first, outer, okay, that worked. But now inner would be these two, and I've completely skipped this term, right? That's why FOIL doesn't work there. But it's just, I think it's a means of getting you to the distributive property concept. So here we go. There is the answer to that one. Are there other terms? Probably. Sorry, other terms. Were there other methods? I don't think so. Let's check this one out. So I guess here's what I did say in classes. Generally speaking, you probably won't even do the arches for very long. You'll probably just mentally look and go, okay, 2m and m. That's 2m squared. 2m and 2, that's 4m. Negative 1 and m, that's negative m. Negative 1 and 2, that's negative 2. 2m squared plus 3m minus 2. I think that's the method you just kind of do it in your head. Now, when it comes to talking about 7-3, there's a little less doing it in your head as far as just looking. Actually, sorry, there's more of doing in your head because you'll be looking at them in different ways. And, I mean, what's different is squared, 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 difference, difference, difference. And if you're like, what? Oh, I'll tell you in a sec. Let's go to 11. Negative q and q is negative q squared. Negative q and 1 is negative q. Negative 1 and q is negative q. And negative 1 and 1 is negative 1. Negative q squared minus 2q minus 1. All right, 12. I have 2 terms, I have 3 terms. I need to make sure and multiply this term by all 3 terms, right? So we have x times x squared, that's x cubed. We have x times x, that's x squared. We have x times 1, that's negative x. And now we're done with that term. We have negative 2 times x squared, that's negative 2x squared. We have negative 2 times x, that's negative 2x. And last but not least, we have negative 2 times negative 1, that's positive 2. X cubed minus x squared minus 3x plus 2. If you're wondering how I'm getting this stuff right here, you're just combining them. X squared cubed has no like terms. X squared and negative x squared, negative 2x squared would become negative 1x squared. Also, one thing that I just kind of showed you when it came to FOIL and distributive property, and I haven't mentioned it out loud, so I'm going to mention it out loud now, is that when you do that and the things are in standard form, you will get this nice little stair step of like terms. Nice little stair step of like terms, right? He has no like terms, but these guys do. He has no like terms either, right? So again, stair step of like terms. I think you kind of get the idea. And if you're like, but wait, you don't stair step here. Yeah, you do. You stair step, and then these guys are like terms, right? So anyway, that's one reason why I am a fan of like the FOIL/distributive property approach, because of how it can kind of organize things for you. And I've told you before, organizing is kind of important, okay? Now, this one, 3n squared, 2n, 6n cubed, 3n squared, and 1. And now we're done with that one. See ya. 2n and 2n is plus 4n squared. 2n and 1 is plus 2n. And we're done. Negative 4 and 2n is negative 8n. Negative 4 and 1 is negative 4. Check it out. We have our stair step, this, that, this, that, this. So we get 6n cubed plus 7n squared minus 6n minus 4. 14a times 2a is 2a squared. A times 5 is 5a. 1 times negative 2a is negative 2a. And negative 1 times 5 is negative 5. 2a squared plus 3a minus 5. And we have finished 7-2. Now, 7-3, what was special about it is if we had a plus b squared, we could pretty much just think through this and go, oh, well, listen, that would be a squared plus 2ab plus b squared. We could also have this. A minus b squared is going to be a squared. In fact, hang on, let me do this. Let me copy paste this. The reason I'm going to copy paste this is because it will help me illustrate the only change right there. So from this one to this one, there is only one change, and it's that minus. And if you're thinking, well, how would that be? If you're not liking this, don't do it. You don't have to do it. I'm just letting you know that If you don't do these, then you're going to have to use the distributive property or FOIL or box. And check it out, a times b times a. So here's a plus b squared, right? So let's do the distributive property on it. A times a is a squared. A times b is ab. B times a, well, actually that is ab. And then b times b is b squared. So let's see, a squared plus 2ab plus b squared. That's why this exists. That's why these are like special patterns, so to speak, is because if you were to actually do the distributive property, you would get that. Now, I'd mentioned the difference, and that this one was a difference, this one was a difference, and these were differences. So why are they differences? Well, if you had a plus b times a minus b, that would equal a squared minus b squared. And that's it. And again, if you want to FOIL it with me, okay, a times a squared. A times b, negative b is negative ab. B times a is positive ab. B times negative b is negative b squared. Notice how that cancels, leaving us with a squared minus b squared. So I'm going to erase this just for the sake of like clutter. And I'm going to try, if I can, to drag this right here. Boom. There are our three special scenarios, so to speak. Okay. So if you want to screenshot that or whatever, then go for it. Next, let's check these out. This is a plus 3 squared. So I know it is a squared because that's literally a squared, and that's what we'd set up here. And then if you want to, I mean, it's just plus 9 because that is 3 squared plus 2 times 3 times a. You could do that in your head. You could have done that in your head, and you would get a squared plus 6a plus 9 is that one. 16 is 9x squared because 3x squared minus 2 times 3x times 2, which is negative 12x. Let's see, plus 2 squared plus 4. There's that one. And so if you're like, wait, what is this up here? That was me kind of working it out so that you could see that this was the minus 2ab. And if you're like, why is it a minus? Because it matched this one, right? The minus, it's going to have a minus right there. Okay, this one might feel a little funky because of the negative right there, but it's still going to end up being 16c squared because it's negative 4c squared plus, so if you're like, wait, plus, what's this going to be? 2 times the a and the b, and so actually I guess I kind of went out of character here. This is where I've been writing the answer. And then last is plus 5d squared, so that's plus 25d squared. So let's finalize this one. 16c squared minus 40cd plus 25d squared. 18. Okay, so now we have a difference one, which the difference ones, I love the difference ones because it's just that and that squared, slap a negative in between them. So x squared, oh, not plus, x squared 9 minus. That's it, because it's a squared, b squared, put a minus in between them. A squared is 1/4 c squared. B squared is 1/9, put a minus between them. And if you feel a little uncomfortable about like, oh, how do I know it's a minus? Plus, minus, and you might be thinking, well, okay, couldn't they all have something like that? Yeah, but this is identical to that. This is identical to that. The only difference, plus, minus, and that's what is the dead giveaway that it is this difference of squares here. In fact, this one has the term difference of squares. I'll write that down. This thing right here. Difference of squares. Okay. So now we have m squared. We have 4n squared negative. Now, if you're like, but that's a negative and that's a negative, well, it's going to be negative m squared, right? And again, if you're not comfortable with just doing this, go ahead and do the distributive property. Negative m plus 2n, negative m minus 2n. Negative m is m squared. Negative m, and that is plus 2mn minus 2mn minus 4n squared. And you can see the answer. There it is. Okay, so now for the tricky stuff. This is more of 7-3, where we're using these ideas up here to answer these special products. So when it comes to this one thing I showed you was that you kind of just want to find the number in between them that's going to be kind of equidistant. And if you're like, what does he mean equidistant? The idea is that if we have 18 and 20, what's the number in between it? And, well, I kind of just accidentally spoiled it. It's 20. If you have 18 and 22, the number that's immediately in between them is 20. How could you get that if you couldn't just see it? 18 plus 22 divided by 2 will give you 20. So what the heck does that mean? What you're going to do is take 20 plus 2 and 20 minus 2, okay? That will give you 22, because 20 plus 2 is 22. In fact, here I'll do a little highlighting. This one gives you this one gives you this one. And then now here's the reason that this exists, period, is because now it's this. Okay, it's the difference of squares. So you could kind of do this in your head. 20 times 20 is 400. Sorry, 4,000 minus 4. So this is 3,996. 18 times 22 is 3,996. It's surprising how you could do that in your head without, lots of stress. Okay, next. So here's the difference. On this one right here, we approach this one as difference of squares. This one we approach like these other two. Now, my recommendation personally is to go with this top one because I don't want to have to think about subtraction in my head. Just not my favorite. So what I'm going to do is take 109 and make it 100 plus 9. In fact, I don't even know why I wrote this one. 100 plus 9 squared. So that when you do this, now it's going to be a squared plus 2ab plus b squared. It is 100 squared plus 2 times 100 times 9 plus 9 squared. Now here's the thing. You're doing that technically in your head, okay? So that 100 times 100 is 10,000, okay? And then, let's see, 2 times 100 is 200, times 9 is 1,800, plus 81 squared, sorry, just plus 81. And so that you could pretty well add in your head, and so you get 11,881. Okay, and actually, I was thinking 100 times 100, yes, 10,000. But 20 times 20 is not 4,000. It is 400, so this is just 396. Just kidding. All right, this next one, it's going to feel a little overwhelming because there's lots of words. And you might be thinking, oh my gosh, we haven't done any word problems. But it's going to be one of these concepts, okay? So let's just keep that in mind. You're on top of a building and drop a paintbrush from a height of 84 feet. So let's pretend, I'm gonna draw this picture. Top of a building, you're gonna drop a paintbrush. Now, what they are envisioning is you are less dropping it and more tossing it kind of like this, okay? And then you're 84 feet in the air. Okay, great. At the same time, your friend is on the ground below and throws a paintbrush upward. So let's pretend this is your friend and they are tossing a paintbrush upward, okay? And they're not going to make it to the top of the building, so it's going to look something like that, okay? Let's see. The polynomials, that and that represent the height in feet of the paintbrushes after t seconds. Write an expression that represents the distance between your paintbrush and your friend's paintbrush after t seconds. So, right, that represents this distance between. You know, as I did this, I feel like I remember the word difference. That's what in my head, that's what made me go, oh, well, that's how this works. Or perhaps that was just what I was thinking, is that, listen, you're finding the difference. I know it says distance, but you're going to be finding the difference between these two. And when you find the difference in math class equals subtraction. So that's all you're going to do. And then now I had to kind of determine, well, which one is going to be the top of the building and which one is going to be the bottom. So here's what I did. I chose that as the top. And I chose this as the bottom. And I'll tell you why in a sec. So the reason I chose them the way I did is this plus 84 is that 84. Okay, so that's the difference. Is that led me to choosing this one. And then if you want to, you could also like plug in a 0. And if you plugged in 0 right here, you would get 84. So it's got to be this guy. Your friend was not 84 feet off the ground. In fact, he's 5.5 feet off the ground when he throws. So we're going to subtract because, again, difference, right? So 16t squared minus negative, these cancel. And then you just get negative 43t, and then 84 minus 5.5, which I believe is 79.5. 78.5. 78, ooh, come on. 78.5. There we go. So plus 78.5. And if you're wondering why is it positive 84 minus 5.5 is going to be much more positive, right? So there's this. This represent the distance between the brushes after t seconds. Now they want us to plug in 1.5. So 43 times 1.5 is 6, negative 64.5 plus 78.5. 78.5 minus 64.5 is 14 feet apart. 14 feet apart after 1.5 seconds. So imagine again that here's the building, and this yellow line is like the timeline. So perhaps 1 second is at 84, and then maybe it's right here 1.5 seconds later, and he's on kind of his own reverse timeline since he's throwing it at you, I guess. I don't know. Don't think about it too much. The idea is that there's the difference, and there is them after 1.5 seconds. So let me know what questions you got. See ya.